Okay, now we are doing 10.10 problem. Alright, so in this problem I'm gonna show you step by step how do you write it. We revised everything now. So we have a beam has a rectangular section 40 and 120 deep and a span of 1 meter. This is 1 meter. The beam is simply supported, carries a concentrated load of 10 kilonewton at the midspan and is subjected to an axial compression force of 50 applied on the beam and calculate what is going on. Let me check the question. So all they want here is calculate maximum stress or maximum stress in the beam and plot the distributed diagram. Okay, so they want the maximum stress in the beam, right? So I've drawn here, I've revised the rules, the technical approach. So number one is to draw a beam and a cross section area, right? Obvious, this is based on the question. Okay, let's come here and draw that thing. So a beam has a rectangular section of 40 and 120 millimeter deep. So now we know the cross section of the beam, and it's rectangular as you can see. It's 40 millimeter wide and 120 millimeter deep. Then a beam has a 1 millimeter span. How do we draw a beam? Just simple one line. Then they are saying simple support, so we have something like this: RL, RR. Then the span is what? 1 meter. Simple. And then carry is what? A concentrated in the mid span. So in the middle span we have this. So we are given that is kilonewton, right? And subjected to an axial compression. Axial means from the side. So from this side, right? We have what? 50 kilonewton. And it's compressive, that means you are getting in. If it was tensing, that means it was going out. So in this case, it's compressive force going in. So it's like, so you're having a rubber here. You have a 50 that just pushes like this, and then you have a 10 that push from the top. I think you understand, right? So this is what we have, right? And then they ask us to calculate the maximum stress. Okay, then number 2 from here, identify the forces and solve them, right? If there's density, we like kg force or pressure, yeah, and then we convert it. If there's density, you convert it. We convert them to UDL, and then this is the form we use. So in this case, there's no UDL, so we skip this stage. Then we are here, categorize them. They are saying here is either direct or bending, right? It's very important. We always start with direct. So here, let's look at a 10. Does 10 causes a direct stress? Let's see. 10 only causes bending stress. You see it's along the thin side of the beam, so it causes only bending. 50 is on the cross section, is perpendicular. So anything that is perpendicular to the cross section is direct, causes direct stress. So 50 is indeed perpendicular to the cross section, because if you look at here, If you can draw a beam in 3D, we have something like this, and then we have that 40 of 120 here, and then that 50x here, and then this 10x somewhere in the center. So indeed 50 is perpendicular to the cross section. That means you have to do direct stress. And then direct stress is just for 50 kilonewton is equal to what? Force over area. So we have what? 50 times 10 exponent 3 over 40 times 120, which is equal to 10.416 Newton per millimeter squared, which is just equal to 10.42 MPa. You'll solve it and understand the unit. So we have something like this. And then from here, it says after we have done this thing, draw, right? So we have AB, right? And then we have BD. We haven't done that. You see, that's why this thing is two parts. For us to draw, that means we have to do this structural analysis. So let's go and do it. I'm gonna do it with a pencil. So what are we told? So if we have W coming up, we have A and B. That means if W is parallel to N, W is the side that is parallel to W, it's A and B. You see, for here, W is going down, that means the side that are going down, they are AB. Remember the initial to the N. W is going in the horizontal, that means this is parallel to W. This side and this side are parallel. That means your A and B can be anywhere. You can say A, you can say B, does not matter. And then from this structural analysis, we need to say y1 and y2 or x2. Remember, A and B is always equal to y1 plus y2, like this. So A and B is equal to what? y1 plus y2. And then again, if it was like this, that means x1 plus x2 is equal to AB. And then we have NA means neutral axis. Neutral axis, neutral axis. These are neutral axis. So let's go and do it. So in this case, it is written here, bending stress is highest priority. That means the force that causes bending stress is highest priority, whereas that direct stress is secondary priority. That means we can only use bending stress to identify A and B. So in this case, the force that causes bending stress is 10. So let's write 10 as it this structure. So we have 10, this. And then the side that is parallel to 10 is this one. So from the structure, so this is A. Remember, from the start to the end, that is B. And then we have a cross-sectional, so the center, the centroid. Remember, this is the centroid. This is X, this is X, this is Y, Y. So this is centroid, remember. It's not like a midpoint, it's a centroid, not a midpoint. It's midpoint because it's just a rectangle. So now we know our A and B. Then from A and B, we need to say this is Y1, this is Y2. After done, then you have 3. We need to find tension and compressing side, right? So for a compression side, to find the compression side, we need to ask ourselves, is it simple support or a cantilever? This is a cantilever. A cantilever, or is it built-in? Built-in and simple support are the same. So let's check. According to this question, it's what? Simple support. Then you can take your wrapper, and then you can see from the simple support, when you press 10 here, it's gonna create this bridge. That means the top part here is compressive, the bottom part is tension. So meaning what? Y1 it's compression, Y2 is what? Tension. Right? Then we are done, and then you come back and draw. So we have A and B, right? Let's call the top part compression, the bottom part tension. Then we have the neutral axis. In this case, the thing that cuts is what? It's XX, and then this here is Y1, Y2. And then you said, remember this is force is compressive. So direct is just squeezing in, pressing in. That means it's contractive throughout the A and B. That means we have something like this throughout A and B. So we have something like this. We have what? 42 MPa, right? And it's compressive. So we are done with draw. Then number 2, we go to what? Bending stress. I think I lost my pen. Okay, pause. Now let's deal with bending stress. We have done with direct stress. There's no other force that causes direct stress. Then now we write bending stress. And then from here we are given that the formula for bending stress is my over I. That means you need to find m, y, and I. Right? We always start with y. So bending stress, we always start with y. From this case, we can see that y is equal to y1, which is equal to y2. What is y? Y is from the neutral axis to A to the other side, and from this neutral axis to B, right? Then in this case they are equal, and then they are equal to what? 120 over 2, which is 60 millimeters. We are done with y. Then we need to find what? I. And then on the previous unit I told that we always cube the side of A and B, of AB. We always cube AB, basically. So I is equal to what? We have this 120 cube times 40 over 12. Remember, this is a rectangle, which is equal to what? 120 cube times 40 divided by 12. So we have what? 5,76 times 10 exponent 6 millimeters. We are done with y, and then we need what? To find m. Now let's try to find m. M is equal to what? It is written here. Only for a simple support, when the sperm is throughout of the UDL, also when the concentrate is at the center, you can use these formulas. I don't know, anyway, you can use the long method. So in this case, let's read. We have 10 in the center, so we can safely use this formula. Remember, this is a load, so and there's only one, so it's WL over 4, and then we have 10 times 10 exponent 3 times 1 over 4, which is equal to 10 exponent 3 divided by 4, which is 250 Newton meters. So we have done this thing. Then we have this. Remember, this y1 and y2. So we can write this one compression. Remember, y1 and y2, we can use this one. If this y and y2 they are not equal, you calculate tension and compression individual based on this. So my over I with 500 times y 60 over I 5,76 times 10 exponent 6 this is mn4. So it's gonna be 500 times 60 5,76 exponent 6. Then what we have here, so we have what, 0 comma, let's change it into, what is this? So we have 0 comma 02604 MPa, tension and compression. Then after this we draw. Then AB, and then we said compression is on top, so compression is on top, and then here the maximum, this is the maximum tension, there's something wrong here. What am I missing? We said 10 exponent 3 times 1 divided by 4, which is 250. Yeah, there's only that force, and then we have this one 16. Oh, here's the problem. This is meters, so we need to fix this thing. We need to multiply by 1000. So the correct answer is not this one. So multiply 1000. So you must be careful with units, guys. So we have 26,042 MPa, both tension and compression. Right? Remember, it's both tension and compression because y1 and y2, they are the same. If they were not the same, you have to calculate individual. So the maximum A and B here in this case is gonna be what? We said compression is on top. Then let's write the neutral axis. In this case is y1. So where is it? A is what? It's compressing. That means, and then you say compressing, that means 26,06 goes up. Remember, this is a compression sign. It must be consistent with the first one. And then B is what? Tension. That means B is going down. Right? And then here it's 0, and then you just join the lines, and then we do this, right? Remember, this is y1, y2. Does not matter if you can, right? Then also this is 26,042 MPa compression. Then we are done basically. Then for result, we just add the corresponding. So for A, we have A here, which is 26 compression, and then you have A, which is what, 10. So 26 plus 10, what is that? So we have 36. So this is a resultant. So we're gonna have 36, which is slightly bigger, 36,46, and then from here center we have 0 plus 10,6. So here we have like 10, does not matter. 26, this is going opposite direction though, it's minus this. 26,042 minus 10.42. So we have what, 15. So 15, remember it's positive. I said tension is positive, compression is negative. That means the answer we find is positive. That means we have 15,662 MPa tension here, right? And then this is your B, and then we just simply join, right? Then you can simply write this one. I have stress. The minimum is what? In this case is tension, which is just 15,26 MPa, tension. Stress max is what? In this case is 36. 36,46 MPa. Sorry, I didn't see you don't see compression, right? Yeah, maximum based on this one. If you can see, this was our previous y by, this is our new neutral axis. You can call it NA, does not matter. So we have something like this. Yeah, thank you guys. Done dusted. So we have calculated the maximum. So the maximum stress is this one, right? And then the distribution is this one. To plot the distribution, this is the plot that they need, not these ones. This one, they'll help you to get this. These ones help you to get this one. This is the one they need, because this is a resultant. This is what is actually happening on the structure when all of these forces are applied. Then you are done. So we have answered this question and this question. Thank you guys. I hope you understand this. So here's the picture. Take it.